All right, for lesson 3.7, after us going over this 2-page notes on elasticity of demand, I'm going to ask you to try the 3.7 daily problem as a Canvas quiz. It's going to go in as a daily problem grade, not a quiz grade, but I did create an assignment using Canvas today. I think this is our first time using Canvas quiz tool. The 3.6 daily problem, I graded 2 submissions already. They look great, so I'm waiting for 30 more of you to submit this soon, before Sunday, please. But 3.7 daily problem will be on a quiz that you will take on Canvas. It's a multiple choice, 5 problems, 10 points each. You will have 3 attempts, and your highest score will be recorded. So I'm not gonna grade this one. This will be graded automatically, the 3.7. I did create it, so if you feel like you're taking this and if you don't see the correct answer or something like that, just let me know, okay? But if I click on the preview, just the kind of things that we're about to go over together, finding I already found something. It says find the price at which review is maximized, not review. I meant to type revenue is maximized. So I'll go and fix that one. I just found out a typo, but I did make this quiz myself. So if you feel like you're taking this and if you don't think something is right, if you can please write me a quick email, that will be great. So as soon as I finish going over the 3 examples in 3.7, I'll go and fix that typo. It kind of bothers me now. I wonder if I can fix it right now while I'm talking to you. Alrighty, but let's go ahead and get started on the 3.7 notes, which I have posted the blank one on Canvas. Let's open it up. If you're I don't know if you're taking econ. I did take it, and we went over. I went over all these, and I think it was a micro or macro, I can't remember. But if you're taking it, you've heard of the word elasticity before. But we're gonna do that using calculus. We're gonna use the derivative to find the function, and then we will plug in some values and decide whether the demand is elastic, inelastic, or has unit elasticity. Okay. Very similar examples, 1, 2, 3. Third one is a little different, but after these 3 examples, I know you will be able to complete your very short 3.7 My Math Lab homework, which only has 5 problems. Like I said, 3.6 and 3.7 are relatively short. So we'll do those both today on Tuesday, okay? Alrighty, let's get started. The learning objective is to find the elasticity of demand function and solve application involving elasticity of demand. The demand function, I think we did have one demand function example in 3.6 notes. It relates the quantity Q of units purchased to the price X in dollars per unit. So think about it. Toilet paper is not a good example because I know if toilet paper gets expensive and expensive, people will still buy it. But say that a burrito price is going up like a lot, and then less and less people will want to buy those burritos. So usually these demand functions are decreasing function because the higher the price, the less demand usually, right? Unlike gasoline, gas price goes up. We don't have alternative. We still have to pay that money and buy gasoline. So what will be a good example? I mean, the more expensive, the less likely you are to buy it. Probably food. But retailers and manufacturers often need to know how a small increase in price will affect demand and total revenue. Because they gotta decide, should we go up on the price a little bit? Will that affect people from buying our product? To measure the sensitivity of demand to a small increase in price, economists calculate this thing called elasticity of demand. And our textbook kind of goes in and derive this formula or the function for us, but I got it here for you. And if you want to know the textbook number, the page number, let Let me see if I can give it to you right now. This ebook, just keep on going back to this ebook. If you look at page 345 to 346, you will see how we really use limit and everything. You'll be able to follow along how they came up with this elasticity of demand function that we're about to just use together. It goes like that. So it will be a negative x times the derivative of the demand function divided by the demand function. So first thing that we're going to do is we're going to be given the demand function, and we will find the elasticity of demand function by using this formula. Okay? All right. And then we're going to do some interpretation. So there are three possible cases. When the elasticity is less than 1, then we say that the demand is inelastic. What does that mean? That means a small rise in price will result in an increase in total revenue. Okay? And when the elasticity comes out greater than 1, then we say the demand is elastic. And it's the opposite. A small rise in price will result in a decrease in total revenue. And when this elasticity comes out to be exactly equal to 1, then we say that the total revenue is maximized. And in this case, we call this case the unit elasticity. Okay? So sometimes we will be asked to find when will this happen. We're going to have to just solve it backward and find the x value that will make the elasticity to be 1. And we'll be able to do that. All right. So kind of the theorem, just organizing what we talked about. The total revenue is increasing at those x values which the elasticity is less than 1. The total revenue is decreasing at those x values for elasticities greater than 1, and we say that the total revenue is maximized if it comes out to be exactly 1. All right, let's find some elasticity functions. Example 1, the demand for video game rental at Clicks Video Games is given by Q equals d of x is 120 minus 20x. So that's the demand function they gave us, where Q is the number of video games rented per day at X dollars per rental. So, I mean, if you think about this function right here, this is a linear function where the y-intercept is at 120 and is going down 20, So it's a decreasing function. So every dollar amount that they increase, it's gonna go down by $20. Not $20. It's gonna, the number of video games rented will go down by $20. So what if we say, well, so we got the demand function. So what are we gonna do with this? We're gonna use this to find the elasticity of demand as a function of x, and which you do know the formula is E of x equals negative x times d prime of x divided by d of x. So let's find the derivative first, because we will have to put that as piece of our numerator. D prime of x equals, well, 120 just gives us 0, but if you take the derivative of negative 20x, you will get negative 20. So if we plug in everything we know here, negative x will be negative x times derivative of d of x was negative 20. And we're dividing by the demand function, 120 minus 20x. If I simplify this, that will turn into 20x divided by 120 minus 20x. So this is the elasticity of demand function for this video game. Okay? All right. So let's find the elasticity at x equals 2 and x equals 5. Okay? So plug in x equals 2 into the function that we just found. What is E of 2? That's going to be 20 times 2 divided by 120 minus 20 times 2. And that comes out to be 1/2. That comes out to be 1/2. Now, they want you to state whether the demand is elastic, inelastic, or has unit elastic, right? So now this number came out to be less than 1. So remember, if we're looking at the first case right here, if the elasticity comes out to be less than 1, we say the demand is, well, the demand, if it is $2, is going to be inelastic. So the small rise in price will result in an increased total revenue. So we will say this indicates inelastic. All right. And they also gave us the different value, right? Plug in x equals 5 into our function this time. 20 times. You know what, guys? We could have simplified this function over here a little bit. We can divide everything by 20. Right, and have x over what? 6 minus x. That would have been easier for us to evaluate. I think I'm going to use that one here. 5 divided by 6 minus 5. That's going to be 5 over 1. Oh, so it comes out to be what? Just 5. Definitely that is greater than 1. So this is the opposite case, right? So if the elasticity comes out to be greater than 1, then we say the demand is elastic. What does that mean? Small increase in price. Small increase in price will result in a decrease in the total revenue. Alrighty. So now the last question. They're asking find the value of x for which the elasticity is equal to 1. We want to achieve what? The unit elasticity here. So plug in 1. We're not finding E of 1, right? This is not what we want. What we're going to do is we're going to set this entire elasticity function equal to 1. So say 1 equals, let me go ahead and I'm not going to use this function. I'm going to set this, that looks simple, to 1. And we're just going to have to solve for x, the price, okay? So if I multiply both sides by 6 minus x, I will get 6 minus x. If you distribute 1, it's just going to be that, equals x. If I add x to both sides, I get x is 2x. Therefore, I get x equals how much? $3. So that is the price that results in unit elasticity. So at $3 per rental, clicks, video games will maximize its total revenue. And that is the significance of this price, okay? All right, the other ones that I got for you are just exactly the same thing, but just kind of working with different looking demand function. So we'll go over example 2 and 3. 3 is a little special, but 2, it's just a derivative that's going to be a little more challenging. So let's look at this together. For the demand function, Q equals, they didn't talk about what kind of product they're selling or, okay, but just the demand function is 100 divided by p plus 4 to the 4th power. They want to find the following. The first is the elasticity. Well, the function is going to be, now it's going to say e of x, but looks like the input variable is p, so let me just go ahead and say e of p. E of p is equal to, just replacing my x's with p's, right? Negative p times e prime of x, e prime of p, and we're going to divide that by the original demand function. What am I saying, guys? Let me wake up my sleeping princess over here. I'll go sleep somewhere else, okay? They're having such a great time. Faith. How you doing, Faith? Now, I wanted to show you my dogs because you commented me about that earlier. So I said, these are it. They're the ones who are snoring right now, but I sometimes get distracted. But anyways, let me go back to the elasticity of demand. All right, so I'm dividing this by d of p. Alrighty. So we need to first find the derivative function. So what is the derivative of d of p? Oh, hold on a second. Now, I know usually that we try to use the quotient rule, but I think I'm going to try to avoid it. Let me go ahead and rewrite this so that it is 100 times p plus 4 to the negative fourth power. And then I'll take the derivative of that using just the power rule and possibly the chain rule for the inside part. So the 100 stays right there, but what comes down? The negative 4 comes down. And then I will have p plus 4, that's getting raised to the new exponent of negative fifth power. And I really have to multiply by the derivative of the inside part, which is just 1. So I really don't have to multiply that by 1. So if I simplify this, the derivative of this demand function will be negative 400 over, and I'll just put this p plus 4 to the fifth power in the denominator. So that's the derivative of the demand function. So I'm gonna have a fraction over fraction, which is okay, but it's just all right. So I'll put that over here. Negative p times negative 400 divided by p plus 4 to the fifth power. And then we're going to divide this by the original demand function of 100 over p plus 4 to the fourth power. We found the elasticity function, but I am sure we're going to have to simplify this a little bit if you really want to use it. So let me go ahead and simplify the numerator first. If I multiply this or simplify this, negative and negative will turn into positive. I will have 400 p over p plus 4 times 5, right, to the fifth power, right? And I'm multiplying, I'm going to go ahead and just say that because dividing by this denominator, you see, dividing by this denominator is same thing as multiplying by its reciprocal, right? So let me just go ahead and say that I'm going to be multiplying by the reciprocal of that denominator. So I will multiply the first fraction by p plus 4 to the fourth power divided by 100, okay? So let's go ahead and simplify this. 400 and 100, I will just have 4p left. And notice there's p plus 4 to the fourth power, and this is p plus 4 to the fifth power. So I'm only going to, this will be completely gone, and this will just go down to the first power. So it kind of simplified very nicely. I will have 4p over p plus 4, and that is the elasticity function for this demand function. Okay. So B, they want you to use the function that we just found and evaluate P of 6 or P at 6. So the elasticity at 6 is equal to 4 times 6 divided by 6 plus 4. That will be 24 divided by 10. And this number is greater than 1, right? Remember, if the elasticity comes out greater than 1, then the demand is elastic. Okay, the demand is going to be elastic. This implies elastic demand. Okay, so the small increase in price will result in what? Decrease in the total revenue. Alrighty, C. Find value of P for which the total revenue is maximized or maximum. Okay, so what do they want? Total revenue is maximum. What they want is for which X value, or in this case, they were using P, right? For which P value will the elasticity come out to be 1? So let's set our function, our good function, equal to 1. So this is what I'm going to set equal to 1 for part C. 1 equals 4P over P plus 4. Multiply both sides by P plus 4. Boop, boop. We'll get P plus 4 equals 4P. Subtract P from both sides. We will get 4 equals 3P. Divide by 3. P comes out to be, now we're talking about price here, right? So instead of me giving them 4 over 3, I can give them a decimal. Oh my goodness, what is 4 over 3? What is 4 over 3 in decimal, guys? 4 over 3 is 1.3 repeating. Hey, 1.3 repeating. So that's it. If the price is $1 and I'll just say 33 cents, we will say that the total revenue is maximized. Okay. Now the very last example, very, very similar to what we are doing, but this one comes out a little bit cool. It's slightly different, okay? I'm trying to remember to go back and fix that one typo where I said price to which the review is maximized. Well, I'll do that. I'll do that soon. All right, last one. The demand function Q equals D of X equals 500 over X. Let's first find the elasticity. That's going to be E of X equals negative X times the demand function's derivative divided by the demand function. So we're going to have to first find the derivative function first. I will rewrite this D of X as 500 times X to the negative first power, so that it's just easier to take the derivative. Negative 500 times X to the negative second power, right? So the derivative function is negative 500 divided by X squared. So that will be that's going to get multiplied to my negative X, negative 500 over X squared. And then I will divide these guys by 500 over X, okay? So now let me go ahead and simplify this numerator, okay? Let me go ahead and work with that numerator first. First, negative of negative times negative, that will turn into a positive 500. But if I have X to the first power is getting divided by X squared, that will just give me X back. Now I'm going to go ahead and multiply this by the reciprocal of the denominator. Okay, the reciprocal of 500 over X is X over 500. Oh my goodness, something cool happens over here, right? 500 over X times X over 500. That will just turn into 1. So we got this cool function. The elasticity of demand is going to be 1 for this demand function. And when they ask you, hey, find the elasticity at X equals 6, I try to plug in 6 in there, but it just comes out to be 1. So state whether the demand is elastic, inelastic, or has unit elasticity. Well, it already has the unit elasticity. If it comes out to be 1, that's what we say. That means the revenue is already maximized. So the value of X for which the total revenue is maximized, it doesn't matter, right? Now just try to give you the exact wording. I think the wording that you're going to see is, it doesn't matter what the price is going to be. You know what? I can't find the exact wording of it, so I'll go ahead and just write it myself. So the total revenue is independent of X in this case. So it doesn't matter what X is that we plug in. The elasticity is always going to be 1. It's always going to be, the revenue is going to be maximized. So the price doesn't matter in this case. And that one was a little special case because we didn't have to solve for that X value. X can be any number. So that is it. See, told you it's going to be a very short lesson for 3.7. 3.8 is going to be slightly longer, so we'll do that on Thursday. But we're catching up. We're doing our best to catch up because we want to make sure that we go over everything in the next 1, 2, 3, 4 weeks. And like I said, we'll be a little busier, but we'll be able to do that, okay? So just kind of showing you the plan that you'll be able to see on Canvas, but I will be adding the lesson notes and like a smaller assignments for daily problems for these weeks. But right now we are just working on week 13.